All right, let's look at this problem. Minimum number of arrows to burst balloons. Okay, there are small spherical balloons taped onto a flat wall, and that represents XY plane. The balloons are represented as a 2D integer array points, where points I equals to x start, x end. Okay, denotes a balloon whose horizontal diameter stretches between x start and x end. Okay, you do not know exactly the y coordinates of the balloons. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. The balloon with x start and x end is burst by an arrow shot at x if x is less than between this. Makes sense? There is no limit to the number of arrows that can be shot. A short arrow keeps traveling up infinitely, bursting any balloons in its path. Given the array points, determine the minimum number of arrows that must be shot to burst all balloons. I guess it's interesting. Now, let's just try to understand the system here. So what I understand is there can be different balloons, and and essentially a balloon is an interval here, right? So a balloon, this might be one balloon, and the other balloon could potentially be this, and there can be like vertically there is no limitation. One balloon could be like that, right? So these can, and obviously you can have some more spaces and add some balloon here. I don't know, add some random balloon here, right? Anything like that. And essentially, our ask is how many. What is our ask? Find the given the array points, return the minimum number of arrows that must be shot to burst all balloons. So, for example, for these three, they all of these three overlap, right? So I could potentially have a single arrow at the right position that could burst all of the balloons, right? Fair enough. So I have to figure out how many such overlaps exist. Mm, Now it could also be possible that it's something like this, and then maybe bring this closer. I don't know, something like this. Now, if a balloon is already burst, then you wouldn't want to, like, basically this guy is having intersection with both of them, but there needs to be a one balloon here and another balloon here to burst. Hmm. Ho, 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 ho. This is definitely an interesting problem. Essentially, we have to find the intersecting points, right? And that I can find by sorting the array initially based on their start thing. And then the minimum number of arrows to burst balloons would be hmm. Now I can figure out that I would require two balloons here, sorry, two arrows here. And the way that I'm figuring it out is so I sort the arrays based on their starting times, and then I see for like for this, so this will be the first guy that I check, obviously. And for this, I'm going to check the next guy is intersecting. So when the next guy is intersecting, that means I've got some point. And then, um, but this is not the next guy, right? This is the next guy, correct? So this is the next guy, and then this is the next guy, and there will become a point where the next guy, which is this, no longer intersects, right? hmm At that point is where we stop and say, okay, this will be my second starting guy, and for all of these, I have one balloon. So this guy intersects uh, with the this guy intersects. This guy also intersects. This guy also. There could be a point where, like this, another case could be like. could be like this, which is let me try and explain something like this. So this first balloon and the second balloon, they both of them intersect. But the third balloon, when it comes, it does not intersect with the previous guy. It does intersect with this guy, but it unfortunately does not intersect with this. So this will require one arrow, and then this when you look at this, both this and this are done, right? Both. Um, so now what you will add, you'll remove both of you'll ignore these two. Both this and this are done, and this is my third guy, and nobody next guy doesn't intersect, so it will require another one. Then this is the next guy. This guy intersects with it. This is another one. So you have to check whether the next guy intersects with the previous guy or not. If it does, keep continuing. Otherwise, uh, if it does, keep continuing. Otherwise, just stop and start counting again, right? So let's look at that if it works for different examples. So three examples that are given to us. First example is, let's sort by the start time. So first example would be 1 to 6. And the second is 2 to 8, and then third would be 7 to 12, and fourth would be 10 to 16. All right. So 1 to 6 is fine. So I definitely need one arrow. Now for 2 to 8, it intersects with this. So still one arrow. 7 to 12 also intersects, so still one arrow. And 10 to 12, yeah, okay. No, it's not working out, right? So let's build this. So um, 1, 2, 3, 4, 5, 6, and then this is 2, 3, 4, 5, 6, 7, 8, and then 7 to 12. So it's here 7, 8, 9, 10, 11, 12, and then 10 to 16. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's like this. So yes, it starts with this and it intersects with this. Yes, it does. What I really want is, does the next guy intersect with all of them? That means I have to maintain like the um, start and the end. So this is the start and end will be the smaller one. This is the end, right? Correct. And so when I check, does it match? And the answer will be no. Since the answer will be no, these two are done. And now this is the start and this is the end. And next guy, yeah, so something like that I have to do. So here it's clear. So I'll look at this and I'll say, yes, this intersects with this. And so that is fine. And after that, this, well, so for this, the problem is this does not come within the intersecting range, which is 2 to 6, right? It had to come between 2 to 6, but it is outside 2 to 6. So this will be separate. So, and this intersect, and this works. So that is fine. And for this, the intersecting range would be like if it had come between 7 and like the starting point had starting point obviously will be greater, but if yes, if the starting point is lesser than this, then it would work, right? Yeah. So that is the thing. It's actually just the end point that matters. The start point and the end point. That's the only thing that matters, right? Basically, all the guys whose end points are lesser than this guy, right? And so you will, when you're sorting, you will try and get the largest end point. So you'll sort based on the smallest start time and largest end point. Right. Let's look at more examples. So this is another example. 1, 2, and then 3, 4, and then 5, 6, and then 7. So this is basic 4. Yeah, this is let's look at this example. 1, 2, okay, 2, 3 is another one, and then 3, 4 is another one, and then 4, 5 is another one. Okay, so 1, 2, and 2, 3 intersect, right? So we'll say yes. For next guy, its starting point is greater than 2. So yeah, so we have to stop this. So basically 2 here, yeah. So this is I want to check another example, which is, let's say I had 1, 2, and then I had 1, 2, 3, 4, 5, and then I had or let's say rather, uh, yeah, 1 2 3 4 5, and I had lot of guys intersecting with this. So let's say 3 4 5 and 4 5 and 5, like all of these. So I will definitely need one arrow for this, and which I can take with this as well. Like these two will be one, and these three would be another, or this would be separate, and all these four would be separate. So it doesn't matter. Okay. So if I had sorted like 1 2 3 4 5 and 1 2, then also it would mean the same thing, right? That minimum is what you have to take, and minimum is this. So these two have to be separate, and this has to be separate. Yeah. Okay, so let's try this then. We have to sort arrays dot sort. We go points, and we're gonna sort a comma b based on their start times. So a and b are one dimensional 1D arrays. So you go a of 0 minus b of 0. So you sort by their start times, or the start positions rather. Now you're gonna do is int arrows equals to 0, or I equals to 0, I is less than rather start if points, what is the length of points array? At least one, right? So make arrows equals to 1. And now if I equals to 0, I is less than points dot length and I plus plus. You wanna check? Yeah, I have one more concern. Okay, let's see your concern. So another thing is, let's say you have one big guy, one, two, three, four, like this. You have one guy which is this big, and then you have another guy which starts next, but is very small, and then there are a bunch of different guys which don't intersect with the previous one, but intersect with the still intersect with the bigger array, right? Which is like this, and then I don't know this, and I mean you can have same balloon multiple times, similar size balloon above and above and above like this, right? Now for this two, or you take one. Yeah, you regardless you need two arrows, right? You could merge this with anyone. You could like link this with these three, or you could link this with this. It does not matter. Correct. You need number of arrows doesn't change. Yeah. So you go points dot length. Now if your current start equals to points of 0 0 and current and points of 0 1. Now what I'm gonna do is whatever the next guy is. First of all, if it starts before the last guy ends, right? So if uh, points of I 0, well, first of all, if it's greater than current and, then you just do what? You just do current start equals to points of I 0 and current and equals to points of I 1, and you do this arrows plus plus. And if that's not the case, that means if this guy starts before your current and, then you would do take the minimum and, right, for this scenario. Like for these I'll stop, and for these I'll take separate. So current and equals to math dot min of current and points of I1, and that's it, right? So and we'll return the number of arrows. Return arrows. Okay, let's Run the code. Console. Okay, all three test cases pass. Let's submit and see if everything passes. And we get a wrong answer. But 48 test cases pass, which is good. And okay, the one test case that fails is some edge case. And how do we solve for this edge case? Is it because of this subtract logic or what? Like could I instead of that could I just do like compare um, com instead of subtracting if I pass actual compare. So I don't know, uh, integer dot compare, does that work? So integer dot, I don't know, compare points of, sorry, a of 0 and b of 0. Like why would they introduce this edge case? Like this is, nobody cares about this. Like okay, yeah, obviously this, okay, so let's submit if see that thing works. Now we're not subtracting, so the overflow shouldn't happen, and yeah, it works now. All right.